Well, good afternoon to everybody. We're all doing great, and we're about to start our seminar on Let's Talk About SCIP. First of all, I want to introduce myself, Engineer Ismael Vasquez, the Technical Service Manager with Carmelo, and also GZT Structural Panels. We also have an online Scott Miller. He's our technical support and also sales for the U.S. And also online is Engineer Victor Camacho. He's our Vice President in Sales and Operation for Carmelo and also Structural Panels GCT. Uh, what is SCIP? So the word SCIP is Structural Insulated Building Components. And we've been manufacturing these panels since 2010 up in Long Beach, Mississippi. And that's where we're doing these panels, and also we also manufacture the mortars there. And in Puerto Rico, we also have a mortar plant in Sabana Seca, Puerto Rico. So we've been making building houses all across the U.S. and Puerto Rico and the Caribbean. Yeah. So let's get started with our presentation. So first of all, we're going to be doing an introduction of what is SCIP, right? Structural concrete insulated panels. Then we're going to be doing the description of how are these panels made, right? And the components as well. What applicable building codes across the U.S., also Florida and Puerto Rico, we comply with, and also the thermal characteristic of these panels, which is one of the pluses of this panel construction, and also how they're built a little bit, right? And then we're going to do a showcase of projects that we have been doing in the U.S., Puerto Rico, and also there's other companies out there in other countries doing the same using similar panels. So let's get started here. So Carmelo's been doing business since like 70 years. So we've been manufacturing products all those years, and so we have a long experience making and producing materials. So these panels, structurally insulated building components, were developed in Italy, and so they have more than 40 years. And let's say they're building across the world with these panels, and it's the only skip these skip technologies. GCT has modified, let's say, these panels so that we can, let's say, comply with the building codes all across the U.S. and Puerto Rico as well. So they're designed to sustain hurricanes and also seismic resistance as well. They have a great high insulation R value. We're going to go through the different panel sizes and tell you what R values are they comply. And we've been doing projects for residential, commercial, industrial. We'll see a couple of photos of those projects. And so we've been making buildings all across the U.S. and then the mainland, and also Puerto Rico as well with these knowledge. So let's get a little bit of description of what's a PCM component and what are these panels. So the PCM component it starts with a expanded polyester core EPS, right? And then it has also electric welded wire mesh, okay? And then after the wire mesh, we put 3/4 inch of structural mortar on each side of the wall. If it's the ceiling, then it'll have 3/4 inch underneath the ceiling as well with these structural mortars. And these panels have different widths depending on the span you have between walls. You'll be selecting the width of that panel for, let's say, either for for the walls or the in between slabs or roof, let's say. So they have different numbers. They start with PSM 80s to all the way up to PSM 240. That's then you'll have almost a finished product about 12 inches. So you can go from 5.5 inches to 12 inches with these PSM. So that's the one that we're using for walls. But you can also use them as a span up to 12 feet. And you can also use these PSM panels. Then we also have the PSG components, which are T-beam pocket panels, as you see there in the screen. And we deposit 2 half-inch rebars there. And we can go from span from 12 to 32 feet with these panels. And again, these are mainly used for in-between floors and also for rooftops. Then, just to get some idea of what's the panel composed of, the wire mesh that we use is about 95 KSI, right? A rebar has about 60 KSI, so just to get an idea. And they're galvanized, so they have a minimum fracture of 95 KSI. So the principal wire runs at about 3 inches, and then and then on the other direction it has about 2.5 inches. So that's about the square. We also use structural mortar, which is about 4,000 psi, and we pre-bag those mortars in our plant in Mississippi and also in Puerto Rico, and then to apply the mortar or mix it, we use the mono mix, which you can see there in the screen. We break the bag on that machine, and then it will mix it. Then with a 32-foot hose, then at the end we can spray the hose, and with something similar to this gadget here. This would be where you're going to be spraying also the walls and also the ceiling width here. But this is low pressure. This is not like shock treating. Shock treating it has a lot of pressure. I mean, we don't want to ruin let's say the foam there. So that's why we use low pressure. Okay. So we do comply with the International Building Code, Residential Code, and the Florida Building Code, Puerto Rico Building Code. So we have done our homework doing testing to these panels to comply with these building codes all across the U.S. and again, Florida and Puerto Rico. So, and again, other applicable codes, ICC standard design construction for storm shelter, very important. We also did the test for the impact test and also the cyclical wind pressure as well. And also standards for bullet resisting equipment. We have done jobs in Antarctica where it's below freezing temperatures. And here, this job was very interesting because they had 3 months to do it with daylight. And so they're looking for structure that are warmer inside. So the difference in temperature that you can get in these panels about 30-something degrees out there. So you can use them in cold areas or zones. You can use it in hot areas like these buildings in Africa, and where you get temperatures over 100 degrees. So you want your building to be cooler inside, and again, you're going to benefit with these panels about 30 to 32 degrees inside. Difference between what's in the ambient temperature, and what's inside that building. So just to get an idea of how these panels work, if you look at your left side we're projecting a beam that will generate a temperature of 109 degrees at a 4,000 psi concrete. Let's say this is a concrete wall. And then on the other side, you're going to get about 90 degrees. That's a difference about 16 degrees there in between those that wall. So if you look at our panel, the structural concrete insulated panel, you can start at 109 degrees there with that temperature, but then the foam will mitigate that temperature, and then you see on the right 72 degrees. That's about 32 degrees differences. Okay, so our panel, depending on the sizes, right, with a PSM 80 to a PSM 240, you'll get an R value about from 12 to 34, depending on the thickness of that panel. This is a table where you can see where the PSM 80 can give you an R value about 12. And again, a PSM 240 can give you an R value about 34. And again, the PSG 3, where we use it in between slabs, or let's say on a rooftop, you can get up to 36 degrees. So what testing have we done, to these panels? Structurally, we have submitted these panels to lateral loads where we can mimic, let's say, seismic responses, and then modification factor. We got a 5 there. That's one of the highest for, let's say, in testing. So they had to stop the machine there at 5. Then we also did it with Intertech. We did some testing of projectile impact testing, the task 201. And what they do here is they launch a 2x4 at 80 feet per second, and it hits that wall, right? Then on the right side, you can't, for failing or passing this test, you can't see any material on the other side. So we did pass this test. We did pass this test, and so we report these tests are required by the Miami-Dade and the Florida product approval. Okay. So here we also did the impact test, and you'll get a protection level with these panels of level number 3. Okay, and this product provides a protection of a 44 Magnum round. So again, the testing here is they shoot at this wall, so no components on the other side or any bullets coming out on the other side, as you can see there. So we passed that test as well. So with DRJ certification, we were able to provide a technical evaluation report, and this is equivalent to an ICC-ES for you designers out there. And here you can see all the dimensions of the panels, the R values, the thermal characteristics, the structural capacity, actual load, moment. So all that good information is in there. Then they also have provided a reference table depending on the width spans of the walls. You can select also the panels. And these let's say the DRJ certification, it complies for all the states, all around the states, all across the states as well, Florida and Puerto Rico. Also, we have also been able to get the government permits, right? To, let's say, if you need the construction permit or the use permits, once you have your plans, right, you can submit it, and it'll be given to you, those permits. So let's get a little bit of details on how these buildings are constructed, right? So first of all, you start with a foundation, right? Where you put your foundation wire and all that. First of all, or your foundation, you'll need a polyethylene, right? A sheet about 10 mils, and then you pour your regular concrete on that slab. You have your finished slab, right, on that floor, and then we start putting dowels every 16 inches. We'll start drilling holes down to, let's say, 7 inches, and we'll be putting dowels and sticking it with let's say epoxy, so that you have enough tension there. So every 16 inches, you're going to be doing putting one of these dowels, and then you'll have 2 lines there of dowel. Let's say if you have a PSM 80, you have a difference about, let's say, 4 inches between those two lines of dowels. And then we start installing those panels one by one, right? And especially once you're putting those panels, that rebar has to go inside our mesh, right? So, and once you put one to the other, then you staple them one next to the other, right? With a hot clip gun. And what else are we seeing here? Then you also have in the corners, you'll have a mesh like this, which we called the interior corners, right? These L shapes. And here whenever you're meeting, let's say, two walls, or you have the roof and the wall, so you at 90 degrees, then you'll be stitching these components together. And then around the windows, we use these U mesh, and so that means that anywhere there's exposed EPS, you need to put some of this mesh. So the difference here between a general construction that we always see, right, versus a SCIP project is see how neat the SCIP project and cleaner it looks like. If you see they're using forms here to pour concrete. So these forms are heavy, so you're going to need heavy, let's say, cranes to move them around, right? And but our panels just weigh just about 1 pound a square foot. So in let's say an 8 by 4 foot panel, that would be 32 pounds, right? Of that. So with two peoples, you can move these panels along and place them, right? So it's going to be faster. You're going to need less people to, let's say, with 5 people, you can work a house about 2,500 square foot. So it's going to be a safer environment, and it facilitates the work for the workers. Here you can see again the traditional, putting blocks, filling them with mortar, and reinforcing them versus using our panels. You can put them two at a time, three at a time, but the best way is to do them one at a time, and it'll be much quicker. So that, let's say, generally people with 2 people, you can put, let's say, or 2 workers, you can put about 300 to 400 blocks in a day. With our panels, you can place about 1,000 to 2,000 square foot. That's why we're saying it's 10 times quicker. So let's go through our profile of projects, and we have done jobs again, commercially, industrial, residential. This is a school we're doing in Puerto Rico, kindergarten, Head Start, and here they use the panels on the walls. Right now we're doing 2 of them, where the other one they're using it on the walls and also on the slab. This is a residential job where they're doing houses, and you can see that the surface it actually looks like concrete. So this means that these panels, every foot of this panel is a column, or it can be a beam as well. So it's a reinforced beam or reinforced column. Okay, so this is another project where we have done housing. And so they start off again with the panel. They spray the mortar on the walls, on the roof, and these roofs are flat. This is a house we have built in Cabo Rojo. This was built in 2016, and in 2020 there was a seismic event about, let's say, a 6.5 in Puerto Rico, and the architect who built this house, he says there's no cracks, nothing happened, and this has a simply supported, they say, balcony there that's about 10 foot. So you can do them with the PSG panels. And again, you can do these types of form. You can do it rounded, or totally rounded, circle. So this project in particular was done in Puerto Rico, near the beach, where Maria entered in 2006. 17. These building was already there, and if you can go over there, it's perfectly fine right now, and nothing happened to it. And again, these shapes, it's limitless. You can go do rounded, square, and again, this is a nice job third party pool in San Juan. Okay, this is a Chili's aguadilla that they did them on the walls. You can also use aluminum or steel on the roof as well, and combine them. Then this is how it looked on the outside. You have walls up to, let's say, 18 feet in this project. Here they use some silos where you can fit about up to 1,000 bags, 50-pound bags, in those silos, and we use the dual mix to shoot and spray these materials. And again, industrial jobs where the walls are high, you can also combine, let's say, columns, concrete reinforced columns, or steel columns. Uh, here's a here's a nice job in Florida. We got Scott in line. Scott, can you tell us a little bit about these jobs?
Sure, that was project is in the Coconut Grove near Miami, Florida. That's been in place. I think that's about 7 years old, that project at the moment. Regarding our products towards resiliency for weather and beyond, that project has been in the cone, I think, of 14 storms so far, and also experienced weather effects in probably 7 events, with 3 major ones, and it is doing just fine.
Let's take a look at the other one. Thanks, Scott.
You're welcome.
How about this one, Scott? Scott, how about this one?
Oh, okay, that's in Shalimar. That project is in the Panhandle, Florida. That one. It's almost exclusively built with our components. Almost everything you see there, of course, the roof has been tiled, but the roof, the exterior walls, all that exterior work of the balconies and columns is all panel work.
Okay, let's take a look at the other one.
This is a project in Vero Beach, Florida, Indian River County. This project is sporting a hybrid roof. Timber frame happens to be cypress tongue and groove. The detail is kind of interesting, but basically what you're looking at is a panel roof that is sort of a monolithic tile. The attachment from the walls to the roof panels, the rebar is embedded in the walls, pass through the bottom to make the roof to panel connection. So that's a very solid connection. One other, Ismail, can you bring back one? I'd just like to have everybody look at that porch. That's a very significant overhang. That's beach side. That's in the high velocity wind zone. And you don't see a lot of that goes away architecturally speaking, just because of the strength of is not there, but it's very nice to have a very large covered porch like that. Once again, Santa Rosa Beach, very close. That's a house of an architect that likes our system and he decided to design his own. This is a project in St. Augustine, Florida. The snapshots give you a good idea of before and after. That one is a conventional roof is going to be fitted onto the walls. So basically that one is utilizing our system for exterior walls. you can see all the bracing and the openings have been attended to. One of the people in the audience has been involved in this project, and the second one will show you after the border has been applied.
Great, great.
Santa
That
Rosa,
one's very beautiful.
yeah, very good. So you can see, what's been built. It's a beautiful home. So although the components might seem non-traditional, you can achieve traditional finishes and architectural designs. That's a project again in Diamond Head, Mississippi. That is one of the more early projects done with our system. And once again, that's complete system, the roof, the columns, the outside components, there's stairs in there. This particular project utilized almost every facet into its construction. Okay. A project in Port Aransas, Texas, once again, close to the beach in the high velocity wind zones. I'd point out that if you look at the rooftop deck, so it's just a little extra with our system. It's strong enough to use as a space to use rather than for added value, extra real estate value, but it's a very nice place to be and hang out up there.
Nice.
And once again, Huntsville, Alabama, this project too has a rooftop deck, and you can see how with our system, it's easy to arrange and marriage different materials if you like. That's a simple a steel structure to create the walkway that's in black around the perimeter of the house. This project's a data communication center, Lafayette, Louisiana. The demand for this project was that it be very energy efficient. Inside that building is a lot of servers creating a lot of heat. So they needed to be disaster resistant as well as energy efficient. So this project's a great example of how our GCT system can be both.
Okay. So I included additional photos around the world with other countries, and these are from Emedue, which have similar panels, right? This one is I saw it, it was very interesting. It's a kindergarten in Colombia, and you can see how they built even the rooftops, the walls. They used elements to you can see inside there's no column underneath, so they used the panels as beams and columns as well. Very, very interesting, very exciting to see that. Next one. Here, they are also used in Dominican Republic for this hospital. They implemented, let's say, steel columns and steel beams, but all the walls and also the slabs were made with the panels. Also, that you have the curtain walls on the exterior with our panels as well. So you can go up, just with our panels, you can go up to 4 stories. But if you implement, let's say, a reinforced concrete columns and beams, or you use steel beams and columns, you can go up to whatever, let's say how many floors you want to go up, and use our panel as a curtain wall, and also for the interior and also for the slabs as well. So here you can see this office building in Colombia, again, using our panels as our curtain walls, and also used in slabs. And also this office building in Colombia, you see how they can make the design rounded and square, and so it's very versatile to use these panels again. Here, this is a very, very interesting one, where they use just our panels, the SCIP panels, for all the floors, all the slabs, all the exterior walls, interior walls. So you can do it all with the panels just with 4-story high. So it's so you can also do the stairways as well, stairs. They can be manufactured in the plant, or they can be formed in the site. So basically, these are all the projects. So some of the projects we have seen or built out there, and so our technical and sales support is Scott Miller. He's our technical and also our salesperson for the U.S. You can call him direct as well. I'm Ismael Vasquez, and we're supporting, let's say, the U.S., Puerto Rico, and the Caribbean. And Victor Camacho, who's our vice president in sales and operations with Carmelo and GCT, is also available for the U.S., Puerto Rico, and the Caribbean. So these are our Puerto Rico phone numbers and offices in Mississippi. Where if you need more information, you can also email us at info@Carmelo or sales@gctm2.com or Caribbean@Carmelo.com. So for questions, I don't know if you guys have any questions. We can answer some of them right now. So how did you solve the cracks? Okay, which cracks? Well, let's say if there's a crack, you can use crack fillers in those cracks, like as if it's were, like, let's say, regular concrete. Again, you have a 4,000 psi concrete on the walls, on each side of the walls, and also on the ceiling, and over the roof, you're going to have a 3,500, at least 3,500 psi concrete roof. So that concrete, you can put also let's say panels up there, solar panels on the roof, so you can anchor them there to the concrete. And also, if there's let's say fans or other let's say things you want to hang to the walls, it's again you got at least 2 inches of let's say a structural mortar, finished mortar, where you can drill a hole there and put any supports to for anything that you want to hang to. Then I guess, see another question from, do you have any, let's say, do you have any preferred roof coating approved for use in Florida? Again, there's the roof coatings out there, they're limitless. There's fluid applied roof, let's say, coatings. There's also membranes as well, asphalt membranes. So you can either use either or for those to waterproof those roofs. So from the arrangement, there's another question. From the arrangement of the elements in the clear and do not have earthquake problems. Well, it's a very strong structure. We meet with the let's say with the building code. So again, it's gonna be a very safe structure out there as well. Any plan to work with it or needs a specific plan compared to a regular CBS? Well, again, you need a structural engineer, or let's say a design firm, to do the plans and also stamp their let's say their license to those plans, so that you can have a safe structure, right? And also get the permits with the government as well. So what is the design of the mortar that you use to project? Well, we make this, well, let's say we manufacture this mortar with specialty admixtures and fiber as well. So, but the main thing is that we submitted with our panel that the mortar has to be 4,000 psi. Okay. So I have another question here. Is that connection of the SOG vertical rebar only epoxy to the foam? Did I miss the solid connection between the panels and the SOG, as well as between the walls? Well, when you're joining panels to panel, you're going to use an L shape. I don't know if you guys are seeing this L shape here on the screen. And this is how we connect in between when you're joining walls or when you're joining the rooftop with a wall. So they're called L, and they're used interior and also on the exterior of those walls. Or okay, so the only rebar you need is to anchor. We put dowels on the, let's say, on the floor, and you can do those two lines of doweling every 16 inches, and then that's where you're going to install your panel. So that's where or unless the structural engineer wants to, let's say, make a beam or make, let's say, additional reinforcement, and that's in the plan. So you have to include that rebar as well. Okay. Any other questions?
Sir,
Oh,
can I ask a question, please?
sure, go ahead.
Okay. We would like to know what design they use for the mortar.
Okay. It's a 4,000 PSI mortar, but it's pre-bagged. Yeah.
Okay. Mortar. The mortar is component to sand, to cement.
Cement, and it'll have some admixtures in there, and we also use fiber in all our bags as well for all our mortars. Yeah.
Okay, thank you.
All right. Great question, Victor. So I have another question here. There are some certification in place pertaining to Canada. Reach out to me via email. So Scott, you need to go out there in Canada, get some training out there.
You got it. Are you hearing me when I speak, everybody?
Yes.
Okay. I just wanted to throw 2 cents in on, there was a connection about the solid connection from the slab on grade, the SOG, slab on grade to our panels. And the important thing is, yes, you epoxy rebar in, and that's a well-connected, good connection to the slab. But as it goes into our panel, he was pertaining to only touching the EPS. Or what happens there is that the EPS is removed, and then what is a void after the removal of the EPS becomes basically filled with mortar. So it's totally encased in mortar at that point.
Question. What is the cost per square foot for the panels? Average.
Scott?
When you're using our system as if you're including roof and walls, roof panels are typically a little more expensive than wall panels. So panels, the mean of the wall and roof, and with connecting mesh and mortars is tracking typically in the $7 to $9 range for the products.
Yeah, per square foot.
Per square.
That's for the panel, the reinforcing connectors, and the mortar mix.
Correct. There'll be other items, the rebar is not included. This is just products that would be sourced through us. So the panels, the connecting mesh, and the mortar.
I don't know if you know this the answer to this. If you were looking at 1,000 square foot house, how many could hold in a 40-foot container?
Victor, you know it? How many square foot you can fit in a container? 40 foot. 6,000 square foot.
6,000 square foot in a 40-foot container.
Yes.
One other question. What's the minimum height and size of a panel, and what's the maximum height and size?
Well, the maximum height we have is 20 foot for the PSM, and for the PSG, it's about 32 feet maximum.
maximum height. What's the average
20,
width? Is
20
it
feet.
4?
20 feet.
No, you're talking about height. I'm talking about
Yeah.
width now.
So the width is 4 feet by 20 feet. All our panels are all 4 feet.
All of them are 4. So it's 4 by 20 is the maximum height for what type of panel?
PSM.
PSM. And the other one is 4 by 32. That
30,
one is
32, right.
Yep.
that is for the those are for the spans for the roof, right?
Right. That's correct.
Okay. Also, dimension thickness wise, we go from a PSM 40, which is basically finishes out around 4 inches, all the way to a PSM 240, and that might be finishing out around 12 inches with many stops in between different varieties.
Okay. One last question. I've used this product before to build, and after spraying, I don't know if it's because the mortar mix might be curing a little bit too fast, but you get what I would call micro cracking.
Yeah.
Where you get a lot of, it's not structural, it's just aesthetics. What is it that you guys have utilized to eliminate those cracks? Is there anything special?
Yeah, Edmund, and all our bags, what we use is we use fibers in there. So it's liquid fiber and also filaments, fiberglass fibers as well. So that helps, let's say, control the cracking in the mortar for plastic cracks.
There's probably more. Yeah, and I would also say that it sounds like you're in the islands, and when the structural mortar is very high in cement content, and shrinkage cracks is something that is a reality. What you mentioned is non-structural, and that's what it is. Most any sealant or coatings will address all of that. It's really good. That's where using a good quality product that has good bonding and flexural qualities can really eliminate that. As a contractor, callbacks are something you don't want. So as a non-structural crack, it's mitigated by using good sealant.
Do you guys have any lime in the mixture?
We do have lime in our products, yes.
I just needed to know, what besides cement that you have inside the mixture.
Yeah, why don't you reach out to us and we can talk a little bit more in detail. Of course, we have our formulations that we won't directly share, but
Cool.
if we can help, we will.
Okay,
Plus,
thanks.
in our area, we use the structural mortar, because it's mandated to use the structural mortar at 3/4 inch over the mesh. But then you'll probably get some of the let's say small little cracks. But we use let's say finishing mortars 3/8 of an inch on each side, and that will cover all those small little cracks that you see. So all the aesthetics, you can use synthetic stucco as well, and that will cover the those small little cracks as well.
Let me ask one more question. If I was supposed to add a plasticizer to your mix, would that in any effect deteriorate or nullify the 4,000 PSI?
It's good to communicate that to the manufacturer first. I mean, to see what admixture you want. If you want it, if you want to, let's say, include, let's say, a super plasticizer to make it more fluid. I've seen other customers use it with our products because they want to form it sometimes in some areas. But yeah, if you can tell us later on what type of admixture we then can approve or not approve that for the use. Yeah.
Thank you.
We got a question we here that they're looking for a list of engineers and also contractors in Puerto Rico. Yes, we have a list of contractors and also a list of designers for our panels. Every month we're giving training to groups of contractors, and we're building up a huge list of people so that there are available or they're available whenever your job comes in. Also in the States, again, we're picking up more structural engineers and designers to help us design with these panels. So I see another question here. How can we do the design and analysis for SCIP to check the stability and load bearing capacity? Well, with our DRJ certification manual, we can send you, if you send us your email, we can send you that manual. That's our technical evaluation report. And there, again, you can see, I think I have one here. Let me show you here. I have a manual like this. So we can send you this manual digitally, and then you can look at all the properties and also design with it. And also, if you have any questions, you can call me or Victor or Scott, and we can guide you through this, through the design as well. I think we're...
Hello?
Okay. Hi there. Hi there.
Hi there, sir. Thank you so much. Hello, gentlemen, for today's presentation. We're fascinated by your product. You know, can you just please reiterate the cost per square foot that you aforementioned, $7 and $9? Would that be accurate?
Yeah, it's about $7 to $9 a square foot, and that's per surface area of the panels, including, let's say, walls or let's say the rooftop. But that's an average, right? An average. Just materials. That'll be the panels with the meshes and also the mortar as well.
Okay.
But it doesn't include let's say the concrete for the foundation or any rebar or the concrete that's going to go over the panel on the roof or in between slabs.
Okay.
Okay.
Question. One other question. Sorry to cut in. One other question. When you said that the coverage is of the mortar is 3/4 on each side, 3/4 of an inch, right?
Yeah, 3/4 over the mesh.
Yeah, in a 50-pound bag, what's the amount of coverage per square foot for 3/4?
We calculate about four square foot per bag. That'll cover about an average about an inch and a half of mortar. Yeah.
Okay.
That's average, an inch and a half. That's the total you're going to be using on each side of the. So that means that
you use an inch and a half on each side, not 3/4.
each side, and then underneath the ceiling as well.
Okay, so it's an inch and a half. Okay.
Right.
Yeah.
Average.
Mr. Blaze, yeah, the coverage past the mesh is 3/4, but total thickness applied to the wall on each side is 1.4 inches, strict numbers, but 1.5 inches is a big number.
Thanks.
You're welcome.
Let's see. We'll do.
Hello, can you hear me?
Yeah, go ahead, Frank.
Hi, guys. I'm planning to build, so I'm at the point of architect already doing the plans, right? My question is, can I use the same plans for SCIP and I can use for CVS, or it has to have some specific reinforcement needs or?
Well, you at least the structural part or the sheets has to be evaluated by a structural engineer or the designer, and so that you can let's say mimic the amount of rebar that has the design, right? So it has to be designed by a structural engineer. Let's say that.
Mr. Baez?
Yes.
We've spoken, and architecturally speaking, the panel can be architecturally speaking substituted for anything. It's very very easy to fit into any type of that, but building codes and building department, it needs to be engineered and specifically for the system.
Yeah, not yet sent to the city. It's just plans is only there just for bank issues.
Very good.
Yeah. So another question that I had, do you guys get to like know specific crew that can build only the shell in the SCIP? Because I have a crew, but they don't have experience in the technique.
Well, there are crews that we can put you in contact once we learn more about your particular project and where it might be. And also we provide training that you can come to our facilities, whether in Puerto Rico or Long Beach, Mississippi, to receive training, or and a technical advisor such as myself can visit your site and train your crews.
Okay, perfect. So the panels are cheap from either Puerto Rico or from Mississippi when you order?
Mississippi.
Okay. All right, thank you. So send me a text and we'll keep in touch. Thank you, guys. Very good presentation.
Good, thanks. It says here, will the recording be, if we will have a, let's say, a copy of this recording? Yes, we'll yeah, we put it in YouTube. So you can again go back and see it as well. So here you can see another question. How can we do the design analysis SCIP to check? We already answered that one. Again, you can use the DRJ certification manual to do the design. Good. Okay. Any contact in Miami, Florida for labor, Scott?
For labor, yes. Once again, there's crews being developed. It was a very difficult thing 15, 20 years ago, finding experienced people, but there are more and more crews now being trained and to promote our system more, we provide a lot of support in training. If you contact me directly, and I can perhaps direct you towards somewhat specific once I can get to know what type of project you have and what crew or person might be best to direct you towards.
Okay. So there's a very interesting question here. Any structural loss when house catches any fire? I mean, after the EPS foam melts because of heat? Yeah, eventually the system is designed to have a 1 hour and 2 hour rating depending on the thickness of the mortar, right? But regularly it'll have a 1 hour rating. If you want more, you can add additional like 3/4 inch on each side, and you'll have 2 hour rating as well. But let's say the foam in that area melted, so there's no problem because like again, you have the structural rebar, let's say the mesh, and the structural mortar, which is 4,000 psi, so you won't lose any structural integrity of that building. Okay. So,
question: where can I get a TER report for the technical evaluations of the product?
Yeah, if you send us your email, we'll gladly send you a copy of not only, we also have the technical evaluation report, but we also have the installation manual as well. Whoever wants one, we'll send them via digital, right?
Furthermore, we have state-specific stamps as just an extra. There's a lot of like ICC and what have you. We are equal to those reports, and we take it one step further. And DRJ Engineering offers state-specific stamps as one more layer of bonification.
Okay.
How do you calculate shipping costs?
That can be done once again, as a ballpark, it depends on the panels you choose. Some people want a very thick panel for the roof or what have you. But the most that we can ship of any single type panel is in the 9,000 square foot for a complete truck. Of course, when you order different sizes, you might not utilize 100% of that truck, but if you utilize 100% of a truck, the rough means, which Victor hit on before, with the 40-foot container, is about 6,000 square feet of panel is a good round number, median number that will ship. So when you know your shipping costs, we don't know where you're at in relation to our Mississippi, but when you know your shipping costs and divide it by 6,000, you're going to get a rough estimate of what that'll cost you per square foot to ship.
We're running out of time, so those questions that we were able to answer online here, we'll take a look at them via Facebook, and also we'll have somebody to answer those questions as well. Or you can also email us as well. Our next webinar for SCIP, we want to do something, let's say, on the construction side. How are we building these buildings? So let's say we'll post in our websites. We'll post the date that we'll be giving that other webinar, so you can also attend there. And I really appreciate the time you guys have spent with us, and to hear about the SCIP products, and you're welcome to write us and call us for any other questions and needs. Okay, thank you very much, Scott and Victor, for being online with us, and as well yourself for being with us on this full hour. And have a great afternoon, and take care. All right.